In the previous video, we learned about the cardinal numbers and how they are a generalization of the natural numbers. But in this video, rather than looking at the cardinality of finite sets, we will consider the cardinality of infinite sets. But to understand these infinite sets, we must first learn about cardinal exponentiation. Here's how it works. We say that the cardinality of A raised to the cardinality of B is the cardinality of the set of functions from B to A. For example, let's find the cardinality of 2 to the power of 3. If we were to construct such a function, there would be two ways we could define f of 0, two ways we could define f of 1, and two ways we could define f of 2. In other words, 2 to the power of 3 is equal to 8. Whenever we raise 2 to the power of the cardinality of some set, we can say that we are taking the power set of that set. The power set of a set is the set of all subsets of that set. And finally, it is time for us to consider the cardinality of infinite sets. In particular, let us consider the cardinality of the natural numbers. In classical mathematics, this is called Aleph null. But in our case, it would be more accurate to call it Beth null. This is what we call a countable infinity. But we can go one step further. We can define an uncountable infinity. For example, suppose we were to take the power set of Beth null. We would then have an infinity so big we couldn't even list all the elements. We call such an infinity an uncountable infinity. In particular, this number is called Beth 1. And yes, we can similarly define Beth 2, Beth 3, and so on and so forth. We now know how to define countable and uncountable infinities in homotopy type theory. Thanks for watching.